welcome everyone here today, and we are excited to have Bill Parker join us.
Again, my name is Bill Parker, and I'm the president of Coins for Alzheimer's Research Trust. In 1995, the founder of CART, Roger Ackerman, was casting about and very frustrated because we knew just about as much about Alzheimer's in 1995 as we did in 1907. He was very frustrated with the state of research, and he said, I got a crazy idea. Let's put pocket change into a bucket, and then we'll take that pocket change and we will buy leading edge research. And so if you want to see one Rotarian who has made an absolute difference, here's the guy, Roger Ackerman. What a wonderful, wonderful Rotarian. Sadly, we lost him in 2018, but his vision lives on. Let's reflect a few moments about the characteristics of Alzheimer's disease. It's made up of two distinct characteristics. One is a plaque of sticky proteins called amyloid beta, and they start building up in the brain instead of normally being flushed as a waste product. And the other characteristic is called tau tangles. And this is where damaged fibers of protein inside the neuron, inside the nerve cell, become tangled, cease functioning effectively, and the nerve cell dies. Here's an illustration of the amyloid beta plaque. And the plaque builds up in sticky lumps in the fluid in the brain, and it starts interfering with the synapses, or the electrical pulses that travel from nerve to nerve to allow us to think and perform. You can see the healthy cells in the lower right. Tau tangles are in essence bent railroad tracks, if you can accept that vision. Tau protein forms railroad tracks that allow the nutrients to flow inside the neuron, allowing it to function, and the waste products of activity flow out of the tau railroad tracks. And for some reason, they become tangled, they cease to function effectively, and the nerve cell dies. And as you know, nerve cells do not regenerate. So when the nerve cell is gone, it's gone. And here's an illustration of the healthy brains on the left and the damage caused by advanced Alzheimer's on the right. And my wife and I had an opportunity to have lunch with one of our researchers. And this guy was absolutely fabulous. And he pointed out that he was going to cure Alzheimer's until he looked at the Alzheimer's brains at autopsy. And he said it looked like an atomic bomb went off. He said, you can't reverse the effects of Alzheimer's. You've got to diagnose it early and start treating it. And what he said was Alzheimer's starts working inside the brain up to 20 years before the first evidence of external symptoms of Alzheimer's becomes apparent. So he said, focus on early diagnosis so that we can start treating the person and try and extend their mental health until such things as heart disease or cancer or something like that kills them. I want to talk about a couple of successes that we have had in CART. Now, the first CART grant was given out in 1999 for $100,000. And the researcher discovered something called LR11. LR11 is today called APOE. And if you take a 23andMe DNA sample and send it in, and they send back all the information about your background and everything, they talk about APOE2, APOE3, or APOE4. And APOE4 is the genetic mutation that predicts that 50% of the people who have it will get late onset Alzheimer's disease. And that's true across all cultures, around the world. That was discovered by our first CART grant. Another CART grant was looking at the difficulty of getting the brain to absorb drugs to fight Alzheimer's. If you get a shot in the arm for any kind of vaccination, it goes right through the capillaries and the veins. But in the brain, the capillaries are exceptionally tight and only small molecules are allowed to pass through. So you got to get the drug into the brain in order to treat the brain. And what this researcher discovered is a method of binding large molecules to small molecules so that the small molecules can drag the large molecules through the blood-brain barrier and into the brain where they can start acting on the amyloid beta. Another fantastic discovery financed by CART was the very first in vivo positive diagnosis. Up until this time, the only way to positively diagnose Alzheimer's was at the autopsy. And what he did was he discovered that there's something called Pittsburgh isotope beta, and it's a very short very short life atomic particle that is injected into the individual's vein. It goes to the brain and it causes the amyloid beta to glow under MRI. And this was a positive diagnosis for Alzheimer's. The following year, another of our CART grants found an even cheaper way to diagnose Alzheimer's. She said that the fluid in the eye is the same as the fluid in the brain. And as a result, the amyloid beta clumps are in the fluid in the eyeball. And she had a chemical that is in an eye drop. She places the eye drop on the eye, causing the amyloid beta to glow when a special light is shined into the eye, making it possible to diagnose Alzheimer's through a simple eye test. You know, pocket change isn't a lot of money, but the focus of CART is that we bring leverage. And here are some examples. Dr. Levy, who discovered that LR11, got $100,000. From his discovery, he got 7.2 million follow-on from NIH and 25 million from a private grant. Dr. Landreth, who got 250,000, got a $1 million follow-on, and then a $200 million follow-on grant from GlaxoSmithKline. And in 2009, Dr. Levine received a $250,000 grant, and his research allowed for a $22 million NIH grant. What CART does is it funds these crazy ideas that would not be funded anywhere else, and allows our researchers to prove things, and then allows them to get follow-on grants. And to date, almost every researcher who's received a grant has gotten follow-on funding. So the model works. Here's our grant process. At the start of the year, we call for proposals, and the American Federation for Aging Research puts it on their website. We put the call for proposals on our CART website, and we do a physical mailing to every Alzheimer's research lab listed by NIH. From those grant requests, we get what's called letters of intent. And a letter of intent is about 3 pages long and just roughly outlines the research that the grant applicant is proposing. from those LOIs, we have a scientific panel made up of 3 top AD researchers who are all volunteers. They do this all in their own time. They look at it, they sort through it, and they pick the best LOIs, send them back to the researchers, and request full proposals. Now, a full proposal is about 20 pages long, and it has details on the funding, on who's participating, and what their intent is, and all the good stuff. And from those grant proposals, then the scientific panel gets together with the executive board of CART, makes recommendations. And on the 17th of March of every year, we look at how much money we have in the bank from our donations. From that, we determine how many grants can be awarded. And then we identify the winners and the grant amounts. This grant process takes place every single year. And in May of this year, we're going to give out $1 million in research grants. CART today is made up again of most of the districts in zone 33, 34. So we don't want your district to be a slacker. We want you to join us. We want to see Pennsylvania as one of the listed states. No pressure. As of May of this year, we will have given out 61 grants totaling $10.2 million, all in pocket change. And again, the idea of CART is we put blue plastic buckets on the table at each CART meeting. People drop their pocket change in there. The club CART chair collects the money, deposits it with the district CART chair, and we go from there. The key point that I want you to remember is every dime that is contributed to CART goes to research, 100%. That's in our bylaws. All of us are volunteers, and we're working for the love of CART and for the love of research and the love of Rotarians and all of our family and friends. But find another charity that does the same thing. Here's the good news, and you'll have to bear with me because we just made these decisions 2 weeks ago. We are giving Dr. Susan Case $300,000 in the Roger Ackerman Memorial Grant. This is the largest grant we have ever given in the history of CART. And her study is based on the fact that she's looking at viral attacks in the human brain and the microglia response to those attacks, and how inflammation might be the thing that initiates Alzheimer's disease. That's what we're looking for, is what causes it. And she's pretty certain that the inflammation in the aging brain starts the process. So it's a critical study. Dr. Abbasambre received a $200,000 grant. And just as a side comment, he's from the country of Colombia. And when he was a young resident of Colombia, he was a member of a Colombia Rotary Club. So he explained that he was absolutely delighted to be funded by fellow Rotarians. And what he's looking at is the specific issues with tau. He says that not only does the tau tangle destroy the neuron, but it also appears that there are what he calls tau death seeds that leave the dying neuron and spread to the brain to healthy cells. And he's looking at specifically how this all works, because tau is really the killer. Tau kills the neurons. Tau tangles destroy the brain. Amyloid beta plaques interfere, but tau destroys. Dr. Bartholomew has received a $200,000 grant, and he's looking at capturing the biomarkers to allow us to have a simple blood test for early diagnosis. Wouldn't that be wonderful? Dr. Ma-Ling Wong received a $100,000 grant. And let me see if I can get this correct, if you'll bear with me. Inside the cell, genes are spliced naturally, and they generally work just fine, and they result in creating muscle cells, bone cells, or whatever. But for some reason, in the gene splicing that's occurring inside the cell, something goes wrong, and you end up with an APOE4. So her research goes right back to our original research of our first grant. And she's looking at how splicing inside the cell is occurring and whether there's an ability to prevent mutations from occurring, resulting in Alzheimer's. And just for your information, it's the APOE that removes the amyloid beta plaques effectively from the brain. Dr. Gallardo is looking at anti-inflammatory molecules. Again, he is looking at drugs that will slow the inflammation that may result in Alzheimer's. So his research kind of goes together with Susan Caish's, but what he's looking at is small molecules and actually testing how effective they are in preventing inflammation within the brain. And he's going to be doing that with mouse models, and he's going to be doing that with Petri dishes. And finally, Dr. Si-Hoon Choi from Harvard received a $100,000 grant, and he's the first research that we have financed that's addressing lifestyle. And the question that I get almost every time I give a presentation to a Rotary Club is, listen, it's terrifying about Alzheimer's. What can we do to prevent it? And what he's saying is that there is a hormone called irisin, and it is created when you're exercising, when your body is stressed or through exercise, and it seems to have an effect to prevent tau tangles from occurring. So he's looking at an external method of preventing Alzheimer's disease. And again, there's a picture of one of our plastic cart buckets. And I want to tell you that in March, most of our Rotary clubs went to Zoom meetings. And that pretty much terminated the blue buckets being put on the table. They all went in the closet, and most of them are still in the closet. But in June of last year, we created something called a donor portal. And I want everybody to take note of this. The donor portal allows you to make a direct contribution to CART, either by check, or I'm sorry, by electronic funds transfer or by credit card. And the donor portal is www.mycartfund.org. And so you don't have to put change in the blue bucket. You can send it directly to CART, and it becomes available to us, and it eliminates the middleman.
You know, you can find out more about it now by going online, by going to cartfund.org and subscribing to the Cartwheel, because we've got all of the updated information on the research and what's going on. The progress reports are all on YouTube. It's just really easy to subscribe. If you subscribe, it doesn't cost anything, and just stay in tune with what's going on, because everybody I talk to has an Alzheimer's story.